All right, this lesson is on solving exponential equations using common bases. So how do we solve an exponential equation? Is we hope we can have common bases and solve the exponents. Because the domain is all real numbers, there are no extraneous solutions. It's all answers work. Got it? So the bases are the same. Solve the exponents and we're done. So look at number 1. Are the bases the same? So what do you do to solve it? Take the exponents and make them equal to each other, and then can you solve it? So add 9, divide by 2, and the answer is 8. Do I have to plug it back in to see if the answer is negative or 0 or whatever? No, right? All answers, all domain, right? As long as we did the math right, the answer is right. Okay? Number 2, are the bases the same? Is E a base? Are they both E? Then how do I set it up? What's the exponent on the left? 4w subtract 1 on the right. 5 subtract 2w. Just solve it. So how do I combine like terms? Add 2w. What else do I do? Add 1. What else do I do? Divide. See, did I tell you it would be easier? Number 3. Do you see that the bases are the same? But the challenge here is how many bases do I have on the left? So what do I do when the bases are the same? What do? You add them. That's right. So did you see how the bases are the same? So all I did was add the exponents equal, right? Because that's a rule. If the bases are the same and you're multiplying, you add them. How many C's do I have? 4. Negative 1 plus 2. How do I combine like terms? Subtract 4. That's 3. How about subtract 16? What's that? And then when you divide, what's the answer? Done. Number 4. When you see multiplying, what do you do with the exponents? Add them. Again, when you see it, you add them. Now what? Can you combine like terms? So if I combine like terms, I have k squared. 1 plus 2 is 3k. So I'll just combine like terms on one side. Then I'll combine like terms on both sides. This is now a quadratic. Why do I know it's a quadratic? Because the degree is 2. So how do I combine 3k and 4k? What's subtract 4? What's 3 subtract 4? And I'm going to subtract 11, and that's what? Are you good with factoring quickly? What two numbers multiply to negative 20? And they add to negative 1. What are the two numbers that fit? Negative 5 and positive 4. So if I solve this, the first factor gives me the answer 5, and the second one, do I have to check to see if it's extraneous? No, right? They're all good. Now, number 5. What's different about number 5? The bases, are they the same? So, the key is, could I make them the same? So, 81 can be written in what way? 9 what? Now are the bases the same? Now take each exponent equal to each other, add 26, divide, and you get your answer. Is that way more complicated? It's good, right? You did this last year? Yay, yay? Like review, right? I forgot it kind of, but now I got it. So, to solve this, the bases have to be the same. How can I write 1 over 64 so it has the same base? I want that base. So what can I do to write it with that base? Was that an A? Here. 1 over 64 is the same as. Now, 4 to what exponent is 64? So the fraction just makes it negative 3, right? So 4 cubed is 64. The negative exponent takes 64 and flips it, right? So it matches. So I got negative 3 on one side, a squared minus 4 on the other side. How do I solve this? I don't need to make this equal to 0 because I only have a quadratic term. So add 4 and a squared equals 1. When you take the square root, be careful, the answer could be positive or negative 1. Number 7, are the bases the same? Can you make them the same? Can 32 be written with a base of 2? 2 to what exponent is 32? 5. And then what's there already? You've got to multiply them together if you're going to do that, okay? So when you change the base, the new exponent and the old exponent, multiply. So I got m subtract 9 equals 5m plus 15. Combine like terms. So I'm going to subtract 1. I can do that. How about subtract 15? Negative 9 subtract 15. Is that okay? And then what's the last step? And again, if you did the math correct, do I need to check to see if it works right? We're good. Nothing would make it undefined. 8. What's going to be the common base in 8? And 1 over 12 is simply what? 12 to the negative 1. And the new exponent and the old exponent, they multiply. Now the bases are the same. We can just write down the exponents. Remember, if you're multiplying, you add the exponents. And that negative 1 is multiplying. So the old exponent and the new exponent, they multiply together. So if I combine like terms, I have x squared. What happens when I subtract 2x and negative 4? What does it become? Negative 6. How about negative 3 and 13? So subtract 13 and it's negative 16. Do you know your times tables? What two numbers fit? They multiply to negative 16. Negative 8 and positive 2. So the first factor gives you what answer? 8. And the second factor? Perfect. Turn the page. So, honestly, the only hook is, can you make the bases the same? So 343 and 1 over 49, the common base is going to be 7. Do you know that 7 to the exponent 3 is 343? And you have to remember the old exponent and the new exponent, they multiply. How about 1 over 49? That's 7 to the, and the old exponent and the new exponent, they multiply. So you end up with 6n subtract 12, negative 2n subtract 8. Combine like terms. So add 2. I'm also going to add 12. Negative 8 plus 12. And then divide and I get a half, or 4 over 8. Now sometimes you got to change both of them, right? Like 8 and 128. What's going to be the common base? And the answer is the base is going to be 2 for both of them. So now I need to know my exponents. 2 to what exponent is 8? This one's tougher. You might need to use your fingers. Like 2 times 4 and then 4 and then 10 and then that and that, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. How many 2's did I use? 7. So it's 2 to the 7. Remember the old and the new, they multiplied. There's a 2 subtract here, v. So make sure they multiply. So I got 6 subtract 3v. I got 7v plus 21. Combine like terms. Add 3. What was that, Chris? Subtract 21. And then divide. So when I divide, I get negative 15 over 10 would be the same as negative 3 over 2. Right? Number 11. I need the bases to be the same. And the first thing you look at is you take the smallest base and go, does it work with the number that's there, right? Like 243. Can that be written as 9 to an exponent? No. 9 squared is 81. 9 cubed is way bigger. So I got to go back. So what's another base for 9 is 3. 9 is 3 squared. How about 243? How many 3's does that take to get to 243? 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 2, right? So it's how many? 5. And then, all you write down are the exponents. So that's negative 2p, that's 10p plus 30. Combine like terms. I'm actually going to subtract 10, and then divide. And another way to write that, divide by 6, is negative 5 over 2. Number 12. Can you make the bases the same? When I see a fraction, I think negative exponent. Fraction, negative exponent. So a quarter is really 4 to the what? Negative 1. 1 over 64 is 4 to the negative what? And that's 2x squared minus 5. Now, just write down the exponents. So that's negative 2x squared plus 6. Negative 6x squared plus 15. Be careful of the signs. I'm going to combine these together. I'm going to add 6. So negative 2 plus 6, that's 4. I'm going to subtract 6, that's 9. When I divide, are you okay taking the square root of a fraction? So the answer is positive and negative. What's the square root of 9 over 4? The square root of 9 is, and the square root of 4 is, easy peasy. All right, 4 left. I need a common base. 36 will not work. So what base could I use for 36? 2. So when I see a fraction, that means a negative exponent. Now 216 is simply 6 to the 3. Now just write down the exponents. So I'm going to add 2. And divide. All right, we got 3 left. I've been going quickly, so now I'm going to slow down. Number 14. Can you make the bases the same? So I'm going to get my exercise in. I'm going to take a lap, maybe 2 laps. Hey, did we win yesterday against you guys? Oh, yes, good job. Was it like really cold or like silly cold or any of that? It's okay. Windy? Smoky? No smoke smelling? Well, good. That's the way to end the year, right? Triumphantly. So, if you think you're 14, then 15, then 16. I'm trying to give you a chance to find common bases and solve it before I do it. Do you know you did this last year? Okay. So today was review day. But you're not robots. You forget, right? So we got to review. I promise on Monday, brand new. Something you've never seen before. Are we trying it? Do you know the common base is 25? Or is it 5? What happens if you use 5? Would you get the same answer? You would. What do you think 25 times 25 is? So you could use 25. So let's say you didn't see it, right? Let's say you weren't sure that 625 is 25 squared, right? And you changed it all to 5. You get the same answer. You just have more work at the end simplifying it. If you can pick the biggest base, it makes it easier. But any base that's the same will give you the right answer. Yes? So I'm going to go big, or go home. So what base? 25. So the first one I don't change. The second one is 25 squared. And the last one is 25 to the negative 1. That's a plus 2a plus 6 equals negative 1. That's 3a equals negative 7. That's a is equal to negative 7/3. Did you do that without me? Negative 7/3? Yes. Try 15. 2 more. Can you make the bases the same? What is the only base that works? There is only one option here. 2. That's the only one. I know it feels like it could be a different number, like 4 or even 8. That's all lies. The only one that could work is 2. So it's 2 to what exponent? Negative 4, and there's an x plus 7. 64 is 2 to what exponent? 6. That's x plus 5. And 32, remember a fraction means a negative exponent. That's to the 5. Do you see that? And there was no other option. The only base that could be common is 2. So that's negative 4x, negative 28, plus 6x plus 30, and then negative 20. So combine like terms and solve it. So 6 and negative 4 is 2x. 30 and negative 28 is 2. Subtract 2. Divide. Were you able to get negative 11 without me doing it? Yeah. One more. You will have a quiz on this. Both. Can you graph it? Can you solve it? Review. I'm here. There's no bad questions unless you can go to the bathroom or something.
I really made a mistake.
Perfect. Number 16, common bases. This is an example where there's actually 2 choices. So there's a small choice and a big choice. The small choice is 2, but there's a big choice, 8. Now, if you can't don't know it, then stick with 2 to something and you'll get the same answer at the end. But you can go big. 8 to what exponent is 512? 3. 8 to what exponent? Remember, the fraction tells me negative exponent. And again, the fraction tells me a negative exponent. Now that the bases are the same, I can go 3y squared. I can go negative 6y. Now I'm adding, but it's going to be negative. So when you add a negative, it's just really negative 5y squared. Just the exponents. Combine like terms, so I'm going to add 5. I'm also going to add 6y. Because it's a quadratic, and I have a quadratic and a linear term, we need them beside each other, equal to 0, and factor. What's the largest number that goes into both? And they both have a y. And then factor that out. And then you have your two answers. The first factor, 2y, what 0 comes from there? 0. The second factor, what 0 comes from there? See the hard work we did with polynomials and everything? Like, it pays off, right, as we get like older and older in math. That's it. Solving exponentials. Mr. G Math. Over. Out.